Welcome to our YouTube channel. In this video, we are going to do design of substation gantry structure in Eurocode with robot structural analysis. This is stage 2 out of 3. In this, we are going to apply the load combination to the prepared structural model. Before watching this video, we request you to visit other 3 videos. One is a stage 1 out of 3 where we had applied the primary load to the prepared structural model. Second one is the preparation of substation gantry structure model in robot structural analysis. The third one is the load calculation for primary loads which is to be applied on the substation gantry structure. These 3 videos are kept in our YouTube channel. The link for the video are given in the description. Now let's go to the demonstration of application of load combination to the structural model. This is a model which we had developed earlier, and we had applied the primary loads in that. Now we are going to do the load combinations in this. So for that, doing the load combination instead of applying in this regular method, like go to the loads and clicking the manual combinations and entering all those things, we are going to go in a short way, that is combination table. What we are going to do is we are going to make the load combination in the Excel sheet and applying this in copy paste method. So we need to develop the Excel sheets like this, similar like the robot structural analysis, which it is having a combinations, name, case, coefficient, likewise. So we need to develop some 2 tables. One is for wire spanning parallel, that is no angle of deviations. Another one is for wire spanning inclined, that is with angle of deviations. So how to prepare that? Let we do it in Excel sheet. So first for combinations number, we need to select this. So simply we can drag this. So we are getting the 13 load cases, and the name we can directly link to this table above. Next one is first case. You can see there the load combination. First one is 1 for dead load without ice. So for that case, coefficient, that is partial factor, is 1 because 1D. Next case is our wind load, extreme wind load. For that extreme wind load, the 9th case. For the coefficient, what we can do is we can directly copy this formula, because this formula is interlinked with the reliability level which is showing in the table. Because whenever we are selecting this reliability level in the input data, that value will change. Sorry, in environmental load parameters, if we are changing this 3, so this factor also will change as 1.4. So it is better for us to copy paste the formula in the table above. So we had applied this 9th load, but in our robot model, we are having 2 type of wind loads, 2 kind. One is the extreme wind load, that is a load case from 9 to 17 we had applied for conductor, hardware and earth wire, and 21 to 29 is applied for structures. So we need to combine this 21 to 29 also for load combinations. So what we can do is, we know that 21 means it is extreme wind load for structure, and we can add those with 1 and copy paste we will be getting 21 to 29 are structure wind load case, which we had defined in robot structural analysis here. So 21 is extreme wind case, 21, 22, 23 are extreme wind case, and 24, 25, 26 are high wind cases. Similar like 27, 28, 29 are moderate wind cases. So we are just entering the load cases which we got defined in robot structural analysis. So here we are making formula like we look up case number 9. So it will make us to simplify the calculation of load combinations. So 9 is nothing but it is a 9th column, because start from here 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9th column only this values are added. So now you can see here 21, and coefficient for the same is remain as 9 because both are wind load. Next one case is we need to add this wire tension. So for wire tension we need to add WT in 0 degree without deviation. It is a no angle of deviation. So for that 3 is a load case, and the load combination factor is 1 for this. Now what we are going to do is we are going to just copy paste these values to other loads, because in the second case only the wind load is going to change. So here we are changing wind load case 9 into 10. So accordingly, as we applied the VLOOKUP, this wind load and structure also will change. So for next 90 degree wind cases, this wind load on earthwire, conductor and hardware will be 11. Accordingly, as VLOOKUP formula is worked out, it is 23. Next one is we need to apply minimum temperature case. So for minimum temperature case, the dead load remains same, that is 1 we need to consider. And for temperature load combinations also, load combination factor also 1. And for minimum temperature and structure we need to select this load case 20, because which we had defined in robot structure model. So you can see here in the robot structural model, the case number 20 means it is a minimum temperature and structure. So factor for the same is also 1. You can see here it is 1. And the next one is for temperature load, we need to apply minus 40 degrees Celsius wire tension. So that is the case number 5 to be added as a load combination cases. So factor for the same is 1. So you can see factor for all the values, dead load, T minimum on structure, and wire tension for minus 40 degrees Celsius, all are in 1. So 1 factor is considered. Next one is extreme ice plus snow. So in this we need to consider dead weight as ice load, dead weight with ice load. So that is load case 2. So from 205 to 211 we need to consider dead weight with ice, because you can see here 1 DI are mentioned in the load combinations. And for remaining other 212 and 213 it should be 1, because 1 D is mentioned here. Next one is 205 cases. the load factor we need to apply. We can just copy paste this formula in the 205 cases. So it is 2.5 now. Now you can see here for extreme ice load also we need to consider wire tension for 0 degrees Celsius, which we had considered for 201, 202, 203. So we can just copy and paste here. So with this 205 case is completed. Now 206 case to be done. So for 206 to 202.13 we are having the load factor as 1 only. So we can copy paste that. And for 206 the wind you can also see for all the wind cases, extreme ice plus moderate wind and high wind plus normal ice cases. You can see in the table of national annexure also. The wind, the wire tension we need to consider is for 0 degrees Celsius only. So you can see here in the third column. So it means we need to consider this wire tension alone. So what we can do is we can directly copy paste this for 206 to 211, because up to 211 we are having high wind plus a normal ice. So wherever the wind is coming we need to consider this load case number 3, that is wire tension at 0 degrees Celsius. So in the table of national annexure also it is mentioned the same way. Only in extreme minimum temperature and construction maintenance only the conductor wire tension will vary as a minus 20 degree and T minimum, that is minus 40 degrees Celsius. For 206 wind load cases the factor remain 1.2 until 201. So similar factor we need to apply on structure also. Here for 206 moderate wind in 0 degree direction should be considered. For that load case 15 to be considered. Next one is other direction 45 degree. Again it is a 90 degree. Then for structure we can just copy paste the above formula. Now you can see 27, 28, 29. So for next wind we need to add high wind cases. So for high wind cases we need to select from 12 to 14. So similarly like we need to add the wind load on structure also, that is 24, 25, 26. Now we need to calculate the constructional load. So in that we already added the dead weight. Now the construction load we need to add the minus 20 degrees Celsius wire tension. So it means the load case 4 to be added. So the load factor is 1.5. You can see in this load combination. So similar like here also in the table it is mentioned gamma P equal to 1.5. So we can directly enter 1.5 here. And finally the short circuit forces cases, accidental cases. The short circuit force which we had defined here is in the 18th load cases. The short circuit force without deviation, conductor deviation is 18 case. And the load factor for the same is 1. So finally we had arrived the table. Now we are going to arrive the table for wire spanning inclined, that is with angle. So what we need to do is we need to copy paste this. So in here we need to change this as inclined, and here with angle of deviation. And here what we are going to do is we are going to add this with 100. So remaining load case shall be above cases plus 1. So we can just drag this and paste. So now the name remains same as above table. So this load case remains same, only here we need to change the conductor load cases, because this 3 is conductor load without deviation. So we need to change as a 6. So that is a 30 degree deviation in vertical and horizontal both. So this 3 also remain 6. And for here, instead of 5, it should be 8, that is minus 40 degrees Celsius wire tension with the deviation of 30 degree vertical and horizontal. So similar like for this 3 should be replaced with the 6. All the 3 should replace with the 6. And here in 4 wire tension, that is minus 20 degree Celsius with without deviation should be changed to with deviation of minus 20 degree Celsius wire tension, that is load case 7. And finally this short circuit force, which should be 13. Actually it should be 19, that is a short circuit force with conductor deviation. 19 is a load case for this. So now we can check whether we had applied all the load cases. So here we had applied 1 and 2, and 3 is here, and 4 we had applied here, 5 is here, and 6 is applied in the with the deviation cases, 6, 7 and 8. So 9, 10, 11 are extreme wind cases applied, we had applied here and here. And 12, 13, 14 are high wind cases which we had applied here, and 15, 16, 17 are we had applied here for moderate wind cases. 18, 19 are applied with deviation cases. 18 is a short circuit force we had applied here with the deviation without the deviations, and here with the deviation. So 19 is applied, and 20 we had applied as a minimum temperature in both the with and without the deviation cases. And 21, 22, 23, 24, 25, 26 up to 29 are wind load we had applied to the respective cases. So all the load cases, the primary load cases are come into the load combinations now. Now we are going to apply this table of load combination into robot structural analysis. So for that we can have this. Go to loads. The first combinations alone we need to create manually. So that 30 which is showing in that the load combination number we can copy paste here, and the load name we can copy paste from the Excel to here, and it should be ultimate load stage combinations. So click OK. So you can know that first load cases is load case 1 into its coefficient is 1, and 9 into 1.2, and 21 into 1.2, and finally 3 into 1. So 1 in the factor we can enter 1. Next one is for wind, extreme wind on conductor hardware plus extreme wind on structure. So for that factor is 1.2. You can see in our load combination table. Now this wire tension, we are having the load combination factor as 1. So you can see here 3 into 1 factor and 1 into 1, load case 9 into 1.2 and 21 also 1.2. Click apply. Now you can see here the 201 is displayed here. Now go to loads, click combination table. So in that combination table you can see 201 is displayed here, and its load combination and its a parameter like a type of action and the load cases with the partial factor are shown here. Click edit in this tab. So now go to this Excel sheet and copy all the remaining cases from 202 to 213. Sorry, while copying this, we need to copy from the name column alone. Copy and paste here. So that robot structural will create automatic number start from 209. So you can check whether all the factors are added here. So you can also see here by selecting this tab and display loads, symbols and values. So you can see here all the cases which are added here. So now we need to add, so these are the load cases. So 201 to 213 is a load cases without a deviation. We need to add with deviation. We can also copy paste this load combination table directly like we did for 202 to 213. But thing is that we don't get this series like load combination number which we get defined here, like start from 301 to 313. It won't come. What it will come is, it will consider the default the next series number, that is 214. So we need to differentiate this load combinations with that. So for that we need to again create the first load combination 301 in loads manual combination tab. In that we need to click a new. So here 301 to be entered. This is ultimate limit state combination only. So the definitions remain same as 201. Apply. So here we need to add load case 2, sorry, load case 1 only. So 1 with a load factor of 1, and similar like 9 and 21 with 1.2, 9 and 21 with 1.2 factor, and 6. Only change in this table and this table from 201 and 301 is this conductor tension 3 and 6. So here 6 with factor 1 to be added as a load combination. So here you can see the load combination and its factor. Click apply. Now go to loads combination table. In edit you can see that load case number 301. Now we can copy paste this from 302 to 313. Now all the load combinations are done properly. Thank you. Look description for more related videos. Subscribe to this channel for more updates. Thank you.